Hi, welcome back. We're going to just talk about this last part of the question, 2.4b. Now it says the actual width of the room is 42.6. So it seems like a typical person got fairly close. Suppose we calculate an error. Okay. So they give us a formula for the error. The error would be your guess minus 42.6. So that's the formula they'd like us to calculate. Now this was another reason why I came up with just a random number. So let's say my guess was 40. It seems like I'm off. So we could calculate my error using this example. My guess was 40 feet, and I was pretty darn close. I got negative 2.6 is my error. So now they're asking, can you find the average error and can you find the standard deviation of the errors? And what they're really trying to do is, do you find out if you understand how mean and standard deviation change when you add, subtract, multiply, and divide numbers? They're really trying to quiz you on this. Okay. So notice my error was in feet, but if my error was in meters, I would have to change this formula. Now it says I can calculate my errors, and it seems as if, since they gave me the guess in feet, I can just stick to feet for this calculation. So my average error, I need to know the average, so to figure out the average error, I just need to know the average guess. So the average guess, from back up here in feet, was the mean, 43.70. And when I subtract that from the actual, I should get the error. So 43.7 minus 42.6. Okay. So an average, on average, the class was off by 1.1 foot, and actually off by too much feet. Notice my guess was short. So that answers the question, how good were the students' guesses? Find the mean and the standard deviation. So now I have to find the standard deviation of the errors. So that's interesting because my standard deviation in feet was 12.5. And this is where people are going to be scratching their head a little bit. Remember, if my standard deviation was 12.5 in feet, to calculate the error, I just subtracted. And don't forget that when I add or subtract, spread doesn't change. When I multiply and divide, spread does change. Okay? So here, this is my answer, and it says justify. Well, this is my justification. I'm kind of abbreviating. You might want to write a full, nice, beautiful sentence there. But we've definitely asked it. So then, in a way, though, they also said how good were their guesses. Well, an average person got close. An average student's guess was close. Off by only 1.1 feet, right? However, the spread was really big. And we see that in the data. We see that in the picture. Some people guess way too much. And some people, there was a big bump up here where a lot of people guessed way too little. So most people had a good guess, but some people's guess was way off. So the spread was really large, showing some students with far off guesses. I hope the solution guide helped in your homework. See you tomorrow.